In this video, I'm going to set up this application problem as a linear programming problem, but we're not actually going to go through and solve it. So when you're looking at an application problem, the first thing you want to do is figure out what is it that you are looking for. What is your objective here? So I like to go to the end of the problem. In this particular case, it says what numbers of audits and tax returns will bring in an optimal revenue. So we have two different things here, audits and tax returns. So a nice place to start would be to say, okay, well, let's let X be equal to the number of audits. And then we could let Y be equal to the number of tax returns. So now we have a place to start. We want to figure out what the optimal revenue is. So the revenue is going to be the number of audits times the charge for an audit, plus the number of tax returns, times the charge for tax return. So we want to optimize revenue. So that sounds like it's a maximization problem. So I'm going to say maximize P equals 2,500 times the number of audits plus 350 times the number of tax returns. And that's what we're trying to optimize. That would be our objective function. Now, as far as our constraints go, it says that a tax return requires 12.5 staffing hours and 2.5 reviewing hours. And an audit requires 75 staffing hours and 10 reviewing hours. So we have staffing and reviewing. So an audit requires 75. Well, an audit is X, so that would be 75 times X. And 10 reviewing hours, so that would be 10 times X. A tax return requires 12.5 staffing hours. So that would be plus 12.5Y. And 2.5 reviewing hours, so plus 2.5 times Y. So the first constraint, 75X plus 12.5Y, is a constraint based on staffing. The second constraint is based on reviewing hours. And so finally, the firm has 900 hours of staff time. That means they can use less than 900 hours, exactly 900 hours, but you cannot use more than that. So we would have to have a less than or equal to 900. And the next one would be less than or equal to 155 hours of reviewing time. And so these would be our constraints. And of course, we could put in non-negativity constraints if we wanted to. X is greater than or equal to 0. Y is greater than or equal to 0. Because, of course, we're not going to have negative audits. We're not going to do negative tax returns. So it's kind of implied, but we can always add those in there. So this is a standard maximization problem, which you can do using the simplex method, if you've learned that, or you could do this using a graphical method. Hope this was helpful.